Hello, everyone. This is Chi. Welcome to the AI on Air episode 10 with Michael from Brevis. Michael is actually an old fan of Scott and I, and also now the CEO and co-founder of Brevis, which right now one of the hottest topics in the crypto industry. So welcome, Michael, again. And, feel free to give a quick intro of yourself to the audience first.
Sure. Well, first of all, thank you, Chi and Scott. It's great to be here with old friends. And hi everyone. This is Michael from Brevis. We are building something what we call the infinite compute layer for Web3 and really for everything. And that everything, of course, includes AI. And super excited to talk about the verifiable AI future and what we're doing with Kite today.
That's awesome. So actually, Michael, it's a very standard question. We always start from any guest here. The first one is, so what inspired you to start Brevis? What's the original spark for Brevis birth?
Yeah, for me, right? So I entered this entire crypto space because I see this as a really kind of a transforming technology to really kind of transform and revolutionize how not only just money and the financial market works, but how the entire society works. And in the early days, I saw like promising kind of directions like prediction market. The first generation prediction market was Augur that I was actually quite deeply involved in the early days. And but back then I already saw that if we really want to kind of push this beautiful technology to mass adoption, there are a lot of things that are lacking. And the most important thing that, in my view, as a technology builder and researcher, is scalability, right? So I have really set this as my life's mission to really push blockchain to mass adoption, as you can see in my kind of Twitter tagline as well. Scalability is something that I have been kind of interested in working on for a long time. And specifically for Brevis, we felt that after all these years of like kind of the layer 2 scaling, layer 1 scaling, we have reached the point that we are now seeing a scalability bound if we were kind of constrained to a blockchain-based construct or blockchain-based architecture, right? So because in the end of the day, like on a single blockchain, you cannot really run faster than a single server. So how can we kind of break that bound? How can we kind of change the inefficiency of repeated computation across all the validators to something else, right? So obviously we have been kind of following zero knowledge proof for a while, and we know it is a great tool to migrate compute. That is, if you don't want to do a computer in some very expensive place, you can move it to somewhere else that is much cheaper and do it there and generate a ZK proof that you can verify it in the original kind of the super high cost environment that you want to run on, right? So this is like what really kind of inspired us, that you can really use this kind of a compute off-chain and verify on-chain paradigm to create a computation layer that augment on existing blockchains and bring infinite amount of computation power to it. And that's why we see the opportunity here and really kind of started the Brevis with our kind of entire stack of computation solutions.
Michael, actually, I have a few questions here. I think I'm not following directly with ZK community. I think as far as like a few years ago, the speed multiple to run the same ZK verification is easily 10,000x to 1,000x in terms of the like a normal running time. May I ask like what's the current multiple currently your experience with? And I do see a vision here, combined with off-chain compute and on-chain verification, maybe even some sharding in this case, sharding. It can potentially go, like a scale in a, much more scalable than existing solution. But I feel like it seems that ZK probably going to have a boundary there. For example, minimum I don't know, like 10K, 20K, 10x, 20x the compute if you use like without ZK. But I want to understand your opinion here.
Yeah. So totally, right? So like so for ZK computation, like how ZK works is that okay, you have some super expensive computation environment you want to kind of run some computation on, and you cannot really do it there, so you migrate to somewhere else, which where you have extremely low unit cost of computation, right? So and then you run it there. Yes, you need to generate, in addition to the original computation you're running, you need to also generate a zero-knowledge proof for that computation, so that you can verify the result of the computation easily in that high unit cost environment. And there's this kind of a feasibility gap, exists in zero-knowledge computing. That is like, if a certain kind of a computation, the gap between unit costs of this kind of a blockchain environment and off-chain environment is where what kind of computation determines what kind of computation you can run off-chain and using ZK, right? So you're very right that in just like, I think 2 years ago, nobody thought that we can actually prove Ethereum execution in real time, for example. Back then, the multiplier or in kind of inflation ratio of doing the computation itself and generating the ZK proof of that is about 1 million times. So it's actually much worse than what you kind of just mentioned. And after all these years, with especially novel cryptographic research and also very recently GPU-based or hardware-based acceleration, we're now coming close, very close to that 3 orders magnitude gap. Like basically, it is about 1,000 times more computation to run a proof than the original computation. And this really helped us. And let me give you a very simple example here, right? So like, on Ethereum, right now, the entire Ethereum blockchain is running as a repeated compute or re-execution-based chain. Every validator is running the exact same kind of computation again across the entire network of 800K nodes. So what it means is that if you want to, let's say, compute like one piece of computation, 1 + 1 = 2, you're doing this like at the cost of that one piece of computation, but multiplied by about 1 million times. But if you're using ZK, you can just have one node run that computation. Yes, you'll generate a proof, and that proof costs you about 1,000 more times of the original computation. But for the rest of the network, they can just verify the result of the computation with just a tiny fraction of the original computation cost. So that's where you see the kind of a balance tilts towards using ZK. That is like your original computation environment is so expensive that you can actually afford to move the computation away from that very expensive environment to an off-chain environment where the unit cost of computation is extremely low, generate a ZK proof, and verify very succinct and easy to verify, low cost to verify proof on-chain directly, right? So that's kind of how, why kind of a ZK can actually help to scale a lot of blockchain applications today.
Yeah, that comes to, I think it comes to 2 points, which is very new here, relatively new here. First is use GPU to coordinate and do the verification. I think it's something very new for last 2 years. The other is that I think it makes sense on Ethereum because Ethereum, you have more than 1 million nodes, right? You have 1,100K nodes in this case. But for other chains, for example, the second biggest chain, probably Solana, this type of chain, they probably have only like 1,000 validator. Does that still make sense if you have like a 3-level magnitude smaller number of validators in that case? What's your opinion here?
Yeah, absolutely. So like, I think the kind of a key question is that, do you really want to kind of have your entire blockchain run faster than a single server, right? So like, if it is based on any kind of consensus protocols and mechanisms, there's always this kind of overhead of communication and there's overhead of consensus. And the entire network moves like a single node, essentially. And that's the whole purpose of consensus. And, however, in verifiable computing, you can really kind of branch out. You can essentially distribute work in an asynchronous way and say, oh, okay, you do this, you do that. And then, all of these kind of nodes and the proving, nodes can actually kind of run this computation more efficiently. And, very interestingly, you mentioned like the point of like very kind of large scale chains with very beefy single nodes. And, we are actually in active talks with some kind of a similar profile and similar configuration chains. And their goal is not necessarily scalability per se, but to actually increase the level of decentralization of the blockchain itself, right? So like, let's say you have some very kind of a beefy node that is running huge blocks and with extremely kind of high resource consumption. You really cannot run a lot of full validating node for your network because like you really need that kind of a beefy machine to run all these transactions. However, if you use ZK, and you can have a ZK prover to actually generate proof for the chain execution easily. Now you can really have just like even a mobile phone to validate the chain state. You don't even need to execute the transaction. You just need to verify the proof and say, okay, this very large chain, there's this RPC node is telling me this is like the balance of my wallet, this is the balance of the other guy's wallet. Instead of fully trusting the RPC provider, now I can kind of get 100% proof and assurance that this is actually the balance of this particular wallet or other kind of a chain state, right? So for them, it is ZK is a way to improve decentralization to a level that was not possible before. And for chains like Ethereum, ZK is a way to kind of do scale. So I think ZK is really kind of helping both of these camps. One to kind of achieve better scalability, the other to achieve better kind of a decentralization. And in the end, they're actually going to converge probably. We're going to see Ethereum with 1,000 times bigger blocks, but at the same level of decentralization. And we're going to see chains like Solana with the same level of scalability, but with much better decentralization, all because of ZK and hopefully because of Brevis.
I see. So basically just scale the compute and in the right direction if you need it. It's like a modular ZK compute skill.
That's right.
But I guess modular is actually overused word in crypto world in this case. Yeah.
It is.
Yeah.
Michael, actually, I'm very curious about, goes back to specific numbers that you mentioned. First of all, thanks for, the latest numbers or speed that you just shared with us. So then if we go back to, for example, for a validator, Ethereum validator, if instead of running the normal work as usual, they just need to do the proof right now, then what is that fractional percentage of the speed, right? Because if you want a normal node now to run a ZK verified or a Brevis powered ZK verification, then that's three orders of magnitude that will increase. But for that a node that's just to do verification, then how much the time saved there? I'm curious.
Yes. So basically, what our estimation is that with things like Brevis's real-time proving capability, that we can essentially prove Ethereum blocks in real time and kind of essentially add more machines to kind of what this actually means is that you can start to have bigger blocks on Ethereum. And how bigger is bigger? We can essentially have about 100 times bigger blocks almost immediately today. If we pass all the security kind of checks and everything. So now in terms of the cost is actually going to be reduced by another about 100 times. Now, the beautiful thing about ZK proof is that no matter how complex the original computation is, you are always verifying a very succinct proof with almost a constant cost. We have been talking about blockchains, but you guys have been doing amazing works on AI, right? So but let's say we want to generate a verifiable computation result or verifiable inference result, saying that this AI actually output this kind of particular result. It is the exact same kind of verification cost and comparing to just verifying an Ethereum block execution, because in the end of the day, you're all kind of aggregating and compressing the proof into something called a gross 16 proof, and verifying that is for any kind of computation is roughly kind of constant time. So that's kind of the powerful thing about ZK. So you get immediately 100 times faster, bigger blocks on Ethereum, and at the same time, the gas fee per transaction got reduced by about 100 times. So that's kind of the level of scalability, this kind of thing can enable. But of course, the very important thing here is that you actually need to have a performant enough ZK stack to actually achieve that. And and that's something that a lot of teams, including us, has been kind of working relentlessly on. And the idea here is that because you want to have bigger blocks, right? So then you need to be able to prove that bigger blocks within the same kind of a block time of 12 seconds of Ethereum's underlying kind of approved block producing time. And so that's essentially kind of the goal and the direction everyone is working on. I think right now with Pickle Prism is world fastest ZK VM on that regard, that we can generate the Ethereum blocks proof for current Ethereum block within just 6-ish seconds for most of the cases. And what this means is that we can just simply throw more GPU at this problem to scale up Ethereum blocks, very easily.
I wonder, Michael, have you done any experiment on ZK, ZK running any models here? Because I think the verified Ethereum block is actually one of the simplest compute you can do, right?
Yes.
You don't occupy tons of the memory in this case. And then I think I saw your notes that you're running on 12 GPU in this case, and then do tons of the execution and to meet the 99.6% of the block verification. Do you see any feasibility even running the smallest model in ZK mode in this case? Like, is that feasible?
Yeah, this is a great question, right? So I don't think I don't think it is possible to run any kind of machine learning model in just a VM construct, as is now. It is not possible. And this is like where we actually differ with a lot of the ZK solutions out there. That we know ZK VM in the entire verifiable computation stack is just going to be the glue of the computation. You actually have to have a lot of co-processors or plugins that you can plug into this kind of a glue to act as a holistic solution to address common use cases. So like today we have something called a ZK data coprocessor that helps you to accelerate and reduce costs in the use case of if you want to access and improve some historical on-chain data transactions, such as like the things we do with PancakeSwap, Uniswap, and many others, to essentially kind of generate the user's historical behavior proof and use that to get dynamic fee, a fee discount, performance boost, or like a kind of a revenue kind of sharing on various different systems. So you can actually use the ZK data coprocessor to accelerate a lot of these kind of computation. And I think in the future, machine learning workloads are also going to run on coprocessors. We have previously done some work on that front. We released a paper called SPA ZK. So it's a very kind of specific solution that first convert many of the large language models using ternary networks to kind of convert that into a ternary network, which is like a network with mostly one, and like the weight matrix is like converted into 1, -1, 0 mostly. You got a much larger kind of weight matrix, but you got similar kind of accuracy. The reason we want to do that first is to make it ZK friendly. Like it's kind of a cross stack design from machine learning to ZK. That once you have that kind of a model, you can use something called a GKR protocol based solution to vastly kind of accelerate the ZK proving time by at least 1,000 times. So we do think that running verifiable AI is possible. It is very much tangible. We haven't kind of pushed that work all the way to the end with like models running on it. But the thing that I wanted to point out was that you have to use this kind of a very modular architecture that we really champion here. That is, you have this glue of a ZK VM that is like gluing every kind of a special computation together, and then you have this kind of a coprocessor, specialized coprocessors that are not only just a specialized ZK circuit, but even it is a specialized system that can handle kind of a very commonly seen and the specific workloads.
Interesting. When you mention specialized system, what type of system is it?
Right. So like for the ZK, so we can, for example, for the ZK data coprocessor, right? So like we also have, so it is not just a bunch of special circuits that we wrote, but it's actually it itself distributed systems. So it is itself a parallel system that you can. So for example, if you want to prove a user transaction or a trading volume on Uniswap in the last 30 days, the first step is to essentially prove that every single transaction this user did on Uniswap actually exists on the blockchain. Right, so we parallelized that process to kind of compute concurrently Merkle inclusion proof for individual users' transactions, and then aggregate them together in one single circuit, and in one single proof. And that proof get rolled into the ZK VM. So when it reaches the ZK VM, you already know that all these data are actually belonging to this particular user. This user did this trade, that trade, and the other trade, and in the ZK VM, you're just adding them up. So like the ZK VM can easily handle the kind of adding them up process, but like for some of these kind of a more specialized workload, we offload that into kind of what we call coprocessors. In this case, blockchain historical data forecast coprocessor. And we believe that we actually also integrated things like zk-TLS coprocessor, that if you want to verify kind of a Web2 data from like your centralized exchange account or like TradFi account, you can do that too. So and then kind of roll all these raw data into zk-VM to run computation on top. So yeah, this is like kind of something that we have been thinking about a lot as well. That we really need to use this kind of a novel architecture to solve this challenge.
I guess it's only. Go ahead.
Go ahead, Scott. No, go ahead.
Oh, I guess it's only economic makes sense in this case that you verify some really important data. For example, purchase data, transaction data. For us, it's agent interaction data. In this case, agent reputation. So I think one use case we are exploring with another zk-TLS vendor is that first is that we actually have data stored like an agent card stored in offline storage here, and also but they also have the for example verify the data from Twitter. In this case, like verify you actually own this Twitter account, and then you verify use zk-TLS verify this is actually the tweets you actually tweet on Twitter, and then use these tweets. And also, as you mentioned, as Michael mentioned, like on-chain transactions, ownership of on-chain transactions, combine all this, and then to use the basis for yourself as a user interaction. But this can be easily extended to the agent in this case, because in the future, most likely all the work will be done by agent. You just need to give very high-level command in terms like token exchange, manage your Twitter account, make payment, etc. So all this should be able to verify, no matter it's on-chain or on-chain or off-chain, Web2 or Web3. Web2 probably use zk-TLS. Web3 you can use technology from Brevis, and then use all this as a basis, as a reputation-based score. But this reputation, I guess, use this way to calculate a reputation-based score is a public and trustless, and then so every single agent can trust this score without verify every single interaction with this agent, particular agent or user.
Absolutely, and I think that's kind of a super exciting future, and for sure. And you guys have been grilling me. I should ask some questions too.
Yeah, go ahead.
Yeah. But before you go to your question,
okay,
I just want to clarify one thing. One thing when you say the Uniswap example. So then you say that if we want to verify or like have a zk verification of the user's total trading volume or transaction volume on Uniswap for the last 30 days. That's 30 days aggregation. That's some aggregation. Is that happening in just want to make sure I understand the whole process, whole flow you mentioned. Is that happening in the zk-VM, or it's actually being treated as part of the data coprocessor? As for example, it's a SQL query, and then it's
So like it is. It's actually like the verifying kind of trading volume or approving a trading volume for a user is actually a perfect example of the glue and coprocessor architecture. So if you think about it, right? So like how do you kind of compute a user's trading volume? You essentially add up each and every kind of trades that a user ever did on Uniswap in the last 30 days. So we really need to kind of prove really two things. One, the user actually did all these trades. Two, these trades add up as like $5 million. So the first step, like the user actually did all these trades, are actually proven in zk coprocessor, zk data coprocessor. That is like you are essentially attesting to the fact that this particular user made this trade with a Merkle inclusion proof, right? So like you're basically essentially proving that against the current kind of block header, there exists such a transaction this user did that is like trading Uniswap ETH to like USD with such and such amount. So that is happening in the zk coprocessor. And once you have all these data points proved, the second step is to essentially prove the computation on top of that data points. And in this case, if you're just proving the trading volume, you're just adding them up. And the zk VM is essentially just running a very, very simple 2-line program to add all these data points up. And you can generate a zk proof about that. And the reason we want to build it this way is because it is very easy for you to specify what kind of data you want to access, right? So in the data coprocessor API. But like we also want to make it very easy for developers and users to compute on these kind of data. And this is where the ZK VM really come into play, where you can essentially write some high-level Rust, program without actually knowing anything about ZK, to essentially kind of add all these numbers up, and then you get the end-to-end ZK proof of user trading volume easily. So that's like the kind of a powerful thing that we enable here. That is, you don't need to know anything about ZK, and you can just build a very powerful application that is analyzing historical user profile, historical market condition, and many more. And yeah.
Actually, Michael, I have a very interesting question.
Question after question. Sorry.
Yeah. For audience don't know, Michael and I went to the same graduate school. Michael was in network, started on the network, and then I was in just general distributed system. I wonder, like we have Professor Grego is actually do PySquare in this case. I wonder, like from your perspective, what's the difference between PySquare and the ZK technology you are building? And I want to know your opinions here as well.
Right. So so runtime verification, fun fact, we were actually right next door to each other in a place called Enterprise Work back in UIUC. So back then I was actually doing some form verification work as well. So you got me there because I haven't really followed that much about what's happening with Pi network recently. But I know they have great teams working on formal verification and everything. I know they do something related to ZK, but I just haven't followed them that much. Not sure I have a lot to contribute there.
Okay.
Yeah, but although I have still a lot of questions for you, but I know you say that you want to ask something, so I don't want to beat you up too much by throwing questions to you. So feel free to ask us questions.
Conversations, right? So yeah.
But anyways, I think you also already mentioned a lot of your vision about why your solutions can be useful to AI, why AI also needs verification, which actually reminded me what you also previously mentioned on Twitter as well, that ZK is actually just a bad name for rollups, but really essential and painkillers for AI and DeFi. So I think that's is probably where we can expand and also contribute our thoughts as well.
Yes.
But I'm curious about why made you make that a comments where that's
I think obviously this, AI is super exciting, and this is something that this is an area that we have also been paying a lot of attention to, and you guys are definitely kind of the cutting edge of the cutting edge teams on that, with a lot of amazing technology, and also architecture and stuff that I have tons of questions about as well. But for us, I think the most relevant, things that we want to make AI verifiable. The reason is that, in the future, it's 100% the case that we're going to rely more and more on AI. And, AI is actually going to, right now, if you think about it, the AI is not, we're at this point, we are allowing AI to take over a lot of lower impact work that we currently have, right? So replying emails with just intention based email reply, kind of polishing our tweets and polishing our blogs post and taking notes and everything. So these are kind of a low impact but very pervasive, and I see a future where AI will kind of quickly rise in terms of the level of impact that it has on our life. We're going to very soon rely on AI for education. We're going to very soon rely. My daughter is not talking to me. She's talking to a AI Peppa Pig all day. So this is already happening, and medical is definitely another example. Financial AI, financial system AI is definitely going to take over as well. So once we reach to the point where AI is taking over most of the mission critical use cases, we really need it to be verifiable. There's just no other way, right? So otherwise we're just essentially trusting a black box. Let's say I want to kind of have some diagnostic AI to run some of my run through some of my tests, or health checkup data to see if there is any kind of health risk that I have. And this AI essentially returns me a result saying that you should watch out for this and that. how do I know that AI is actually like thinking, thinking kind of the AI actually made a lot of effort to actually kind of think through this instead of just like being replaced by some crappy AI that is just like kind of retarded. So the only way to actually solve this trust problem is through verifiable inference. And so what is verifiable inference? Verifiable inference is not magic, right? So like the first step of verifiable inference is something called model commitment. So you have like a model that you want to kind of say, okay, I'm gonna trust this particular model, right? So let's say this model has actually passed certain tests. This model has like passed a certain kind of medical task, legal task, or whatever. And once you pass those tests, you can essentially commit the model into something called a verifier key. This is like a magical ZK thing that is like very, very succinct string of numbers that is essentially an ID of that model. So if the model even is changed by 1 bit, the output of that model cannot be verified by this verifier key. So that's kind of like the magic of ZK. And so then you're using and interacting with the model itself. You don't actually need to verify the output every time, right? But let's say you just want to sample and say, okay, wait, I think this kind of output is kind of weird. I want to request you to generate a proof of inference for the output you just gave me. Like, oh yeah, you really need to take care of this and that. You need to eat like 6 bananas per day. I feel this is like suspicious, right? So so now, like, how do I do this? Is essentially ask that the AI model to generate a ZK proof that is corresponding to the previously committed verifier key to assure me that this particular output is actually generated by a pre-committed and fixed model that is not changed or that is not kind of reduced in capability. And so that's what we can bring to what ZK in general can bring to AI. And this is something that we're working on with a bunch of like our co-processor works, because like we're not going to be the only one that's building co-processors for Brevis. It's an open ecosystem, and we're actually collaborating with a bunch of like universities to build out this kind of ZKML co-processors that can plug in easily with the entire Brevis ecosystem as well.
Michael, actually, I think you mentioned 3 things in parallel here, like 3 complete different things here. Like, for example, the first part is about AI explainability. In this case, that's actually what Chi's old department, the PhD department of data science, actually they do. But I think tons of them are not use transformer architecture. In this case, they use a different architecture. They're different approach. Some of them use a different architecture, explainable architectures. Some use transformer, but with some modification, make it more explainable. I think the second part you mentioned is a verifiable, like a verifiable AI inference in that case. Yeah. I actually saw tons of people already do this in production, use TE with open source model deployment. I feel like that's actually more feasible. And then in this case, like you have 2 ways to verify. You can either use a TE machine as an API jumper in this case. So to verify, you actually send this request to OpenAI instead like some random website in this case, or you can directly run the model inside of TE enclave in this case, and then verify that, hey, this is actually this model is producing that result. I think that's actually I saw tons of the company are doing some experiment or research into that part. Then I think the third part is actually repeatable result. I don't know if you read a paper recently last month about Thinking Lab in this case, Thinking Lab, the ex-CTO, the ex-CTO from the OpenAI. Like she left and started this company called Thinking Lab. They raised $2 billion, and then this is actually, as far as I know, the only output. That's why people are joking. This is a $2 billion paper. Say, hey, how to, like the paper is very interesting. Say, hey, how to repeatedly reproduce the result. If you use the same CUDA version plus the same GPU version with the same model, the result is not 100% reproducible. And then even if you took the temperature to 0, the result is not 100% reproducible as well. They basically do some research into that. It's actually I think it's a very interesting paper worth reading. Anyway, I feel like it's 3 different things, but yeah, that's my gut feeling.
Yeah. I think for a lot of especially kind of large language models and kind of larger size models, TE is definitely right now the most practical solution, and this is like why we're not really kind of delving into zkML a lot at this point. And now the interesting thing here is that a TE or like any kind of enclave based solution can smoothly plug into our glue and coprocessor model as well. Like, you can essentially verify the TEEs, because in the end of the day, TE is also generating a proof. The verification of the proof itself is essentially just like verifying the signature. So we actually kind of work with a bunch of teams to actually verify their TE proof, like automata and stuff like that, and then use that proof as a way to essentially drive, combine that TE data with a bunch of like on-chain data as well, to combine TE result and ZK together and generate some computation result to use the on-chain directly for intelligent DeFi and reward distribution and things like that. So definitely, I think especially for verifiable inference, there are this kind of a GPU with a secure enclave attached, and they are very practical. They don't add a lot of they don't add a lot of computation overhead. So I think it's definitely a better solution. Especially in the short term, for sure.
So particularly for single GPU, I think multiple GPU need to configure the network a little bit.
Yeah.
But for single GPU, I think the overhead is only like less than single digit. It's like a less than 10% overhead. Yeah.
That's what I heard. Yes. So I think like if you're just like running large language models today and if you want a verifiable result, TE is probably the go-to solution, and then you can kind of fold that into a ZK VM and then generate like a final kind of output of something you want to verify.
That's awesome. Yeah.
Yeah, go ahead. No, go ahead.
Oh, I thought you have some question. Yeah, Michael. Yeah, I don't know if we keep asking your questions, and any thoughts you're thinking like asking us. We can discuss.
Yeah, well, you guys has been doing a lot of amazing work on kind of this is like really kind of educational for me, because like I saw you guys have been doing a lot of amazing work on AI based payments, especially like you're launching a chain for this which is quite amazing. So what is kind of the main difference between like AI based payments and let's say like just like traditional payments? There's like also traditional payments. There's like the real time requirement between different agents. There's like automation, but like what's kind of the most distinguish the characteristics that you see that differentiate like the entire AI payment process to like let's say human world payments?
Yeah, so actually that's a really good question. I think the most important thing is that all the existing infrastructure are not built for agent native in this case. Take a payment as example. Current payment, you use credit card, that's 30 cents plus 3% fee in this case, or you like an alternative solution. All these are built for human payment. So in this case, you buy for monthly subscription, you buy for goods anywhere between like $10 to few $100. You just swap your card like once a day, something like that. That's for human payment. But for agent, they actually require something more agent native. For example, I want to call an API, I want to fetch a data, I want to rent a GPU, I want to do a research a little bit, in this case, do a compute. And then, so instead of like a very large like shopping e-commerce type of payment, agent requires payment at a smaller scale and more frequently in this case. For example, it could be like instead of like a monthly subscription to OpenAI, agent can say, hey, can I call paper API usage? Just interact with a service provider or another agent to agent payment in this case. So on top of this, then you have, for example, in order to make sure, let's think about the agent flow. Assume that I'm Scott agent, you are Michael's agent in this case. So the whole agent interaction is actually 3 phases. First phase is authentication. I send a request to you, and Michael will verify it's Scott agent, Scott ChatGPT agent, not some random agent. It's Scott ChatGPT agent. You'll say, hey, first is that I verify its authentication is Scott ChatGPT agent. Then we have the agent-to-agent communication. In this case, should be happen offline, like with the direct channel in this case. And then once we have all the agent communication, we want to have agent payment. So it's 3 channels: authentication channel, communication channel, and payment channel in this case. So solving payment alone will not solve the issue, because if you just have a headless payment, like give me a transaction hash value money. That's not how the existing community work. Like existing community where every single agent has ID. They can identify themselves. They can communicate with each other. They can interact with each other and make payment with each other. And most importantly, all the interaction accumulated to reputation to further lower the cost for the interaction. So that's the whole, the whole flow, agent interaction flow. So that's why Kite AI is building infrastructure to make sure to support end-to-end agent interaction flow. But it's built on top of blockchain. Particularly, you can use your wallet signature to verify, hey, this is the Scout ChatGPT agent in this case, and then so my agent can interact on behalf of me, and you can verify my work signature. Say this is actually in the Scout agent, so we can do some interaction and make macro scope payment. So that's why the Kite AI beautiful. There is more details here. For example, instead of we give every single agent direct access to wallet, I say, hey, let's make it session based. So you can define time and scope bounded session. So instead of say agent can access to my wallet unlimited in this case, I say, hey, I'm gonna give you a $50 access session, just good valid until the end of the day today. So the agent can do whatever within the scope in this case. So it's like a 3 tiers ID and wallet. That's what Kite AI is built for. Hope that answers your question.
Yeah, definitely. And I think this is a part that our collaboration really comes in. That is especially also on the reputation side. That is you can essentially generate the ZK proof of your historical behavior and transactions, and then use that as a way to trust freely kind of a guide towards like kind of okay, this is a this agent, you don't need to trust a reputation service. You can just like see the ZK proof of this kind of other agent's historical behavior, and then evaluate it for yourself.
Exactly.
Yeah.
So like recently for last week, it's very popular Expo 2, but Expo 2 is Expo 2 is a tons of Expo 2 and Expo 2 meme coin. But existing Expo 2 only defines something very simple. Just give me a hash, like give me a wallet, and I'm going to make sure I pay you. You don't actually know who is paying you. You actually don't know what paying for. It's just like give me, you actually request a facilitator. In this case, a centralized service API to say, hey, who is actually paying for what services, the facilitator going to verify it in this case. So I think in the future, when agents interact with each other, you can either use a centralized facilitator or you can use a smart contract. And then maybe it could be like escrow contract in this case. And then all the agent payment ID can be done on chain in this case. And then verification can be done by off-chain compute, like ZK off-chain compute, and bring on chain as a receipt and verify on chain in this case. So for example, existing one, like if you want to have this end-to-end Expo 2 payment, you need to trust your facilitator. Two things. First is not messed up. It's a centralized verification. Second is it's able to verify the output in this case. No matter, for example, how do I verify I order Uber Eats got delivered? Like, it's probably much easier to verify I make a purchase or something and then purchase a swap token, like purchase something online, it's actually returned to me. But it's much hard to verify some offline result in this case.
Definitely.
Actually, one thing when you guys started talking about the verification piece, that Michael, like you mentioned about the model result verification, and Scott mentioned like the agent identity and the payment verification. That is where we had a lot of debate in the beginning of Kite about what is the thing we really want to verify. This is just a reminder of some of the some of the history conversations Scott and I had about, because if we look back of the very beginning of this year or even last year, a lot of the verification, I think people mainly start from, especially in the crypto space, the decentralized AI verification is usually talking about like the model piece, or like sometimes like the data verification. But I think recently, especially with the involvement of agents or agentic system, people start trying to put agent into the real work, and then one of the first things that they need to make sure is that the agent is under control, so that when you use the agents, it's not do something crazy. And second is actually you can have a way, no matter if you are the on the side that's receiving some request from the agent and open up, let's say, your website or service to the agent, or you are the side that's actually sending your agent to do something with other person or other organizations agent or agentic service. You have to have a way to verify your own identity and at least the proof that you are not malicious. You are actually trying to do something legal. And yeah, so I think that piece, again, there's no such a concrete comment, but it's just reminded me a lot of the debates Scott and I had about which verification we want to start with, because there's a lot of things we can verify if we want to talk about the end-to-end AI or agentic workflow.
It's definitely, because it's very diverse and heterogeneous, right? So once you kind of enter this world of AI, it's not as simple as human. Human is already complex, but AI's complexity is on another level. Yeah, you definitely have a lot of challenges on that. So on the X402 thing that you mentioned, as you rightly pointed out, I saw a lot of kind of people talking about X402, and I actually also read the initial proposal. It was surprisingly very simple.
It's very simple.
It was surprisingly very simple, and in this kind of a protocol or standard, there was no kind of a definition or requirement to say, okay, we're going to have this payment is definitely going to have to happen on chain or using blockchain at all, right? So I can imagine that TradFi or traditional kind of a payment rails, online payment, electronic payments systems will be looking at this opportunity as well and say, okay, look, we can also do this. We can also onboard agent into our kind of a traditional payment rails and systems, and then let them do payment there. So do you think there's going to be a race between kind of on-chain native payments between agents that embed into this kind of a broader standard, broader protocol for AI agent networks versus the TradFi kind of rails that is maybe not credit card? AI agent may not have credit card, but they can still have, let's say, PayPal account. They can still have Alipay account. They can still have various kind of online e-payment accounts as well. So do you think how this kind of a whole landscape is going to shape out in the future? Just curious about your thought on that.
Yeah, so Michael, I do have a thought here. I think that one of the core thesis here is that stablecoin going to be native currency for agentic AI, for agent. The reason is that every single agent is actually a programmer. They know how to call API, they know how to use the MCP tool, and then it's like a smart or dumb, very smart and very dumb at the same time programmer. So that's why they request programmable money. What's actually most mature programmable money? Stablecoin. Stablecoin with blockchain is the most scalable proof programmable money in this case. So I think in the future, for example, if you notice that WeChat, and Tencent is already doing something, allow agent to make payment without blockchain. It's already happening. It's happening.
Really?
Yeah, it's happening this summer. So I think I think it's around July or June this year. They already published hey, I provide agent a list of MCP server they can make purchase, use WeChat money, or this is Tencent WeChat money. But the thing is that they need to rebuild this infrastructure to support support programmable money API to spend money, MCP server for agent to spend money. But also in this case, it's actually it's basically just a digit. The money is actually a number in their database. It's not a universal money in this case. So I think one of the biggest thesis here is that agent is programmer. Programmer require programmable money, and the blockchain plus stablecoin is already proven technology for programmable money. Not existing payment rail can support this, but I can see that Stripe or WeChat, Tencent can implement some programmable money, not using blockchain technology. But I think it's trending very positive. Stablecoin plus blockchain will win this competition.
Got it. Yeah, I think this is definitely kind of a very interesting, and I do agree. Stable token is the native and the most programmable money that there is currently. And yeah. So then, what about the blockchain, right? So like there are different kind of blockchain flavors and types and solutions. Like if you guys are building a blockchain specifically for AI use cases and especially AI agents, what needs to be different on the kind of a chain level and stuff to kind of make this work really smoothly?
So I think it's a few things here. For example, on chain level, you're talking about on chain level, right?
Yep.
So I think on chain level, the two most important thing is on payment rails here, payment line here. First is that we're not targeting Web3 developer. Most of the developer we're targeting is a Web2 developer or AI developer. In this case, we want to make sure abstract away the complexity for them to give every single agent agent passport, and then abstract away this wallet management. So currently, every single user has this account abstraction. So they will actually, every single agent is spent through like a one account abstraction. So in this case, so my ChatGPT will spend the same money, same account, share with my cloud in this case. So I don't need to fragmentate my money into a different agent. So in this case, and then so we abstract away this part. Second is that most of the user actually don't want to buy token. They just want to pay use USDC or US dollars, and then on-ramp and off-ramp with US dollars. So we assume most of the consumer on our platform, they're going to on-ramp use PayPal, and then let their ChatGPT help them do shopping, research, do all type of things, and off-ramp use PayPal in this case. They don't need to be aware like, hey, there is a developer built on top of Kite AI infrastructure. Assign my ChatGPT agent passport represents Scott ChatGPT. They don't need to be aware, hey, there is a Kite token as a native gas token to facilitate the payment, between stablecoin payment between different parts in this case. So we want to abstract all this away. And then, so that's why, because of this, we actually build a dedicated stablecoin payment line. So it's a whitelisted stablecoin dedicated payment line. So you don't need to compete with other transactions for general transaction block space, and then you can pay in native gas fee, predictable low native gas fee in this case. So as long as we have, we're still building this part, as long as we still dedicated stablecoin payment line, we can do a tons of things, make it compatible with existing bank payment and transfer. For example, blacklist, whitelist, man field in this case to be make sure compatible with existing payment. So tons of things we build on top of this. So as far as I know, I think no other blockchain is doing this today.
Very cool. Yeah.
We are till the end of still 7 minutes. Sorry. I still have a few more.
No, but like
minutes.
really, like we see we really see a lot of kind of interesting ideas starting to pop up. Because our kind of initial adoption is really kind of focusing on DeFi and RWA and many stable tokens. We help a lot of stable tokens grow to the size they are now because we run kind of ZK based reward distribution and the growth program for them. Like we have so far distributed more than $200 million of reward for some of the leading stable token protocols, and then a few other leading stable token protocols are coming up as well. I do see that once I think there's like also yes, stable tokens are very programmable today already, but they can be more kind of AI native as well. Like I feel there's a kind of a opportunity there to we have been kind of talking to some of these kind of stable token partners recently. That is can we actually kind of integrate some functionality that is like account abstraction native support and have some kind of a way to do gasless payment embedded in the stable token directly, so that you can just like you as a user can run a AI agent that receive and send stable token without actually kind of being without needing to essentially kind of have gas feed and all the complexity to interact with the underlying blockchain. And these are the kind of discussion points that came up a lot. And I think ZK can definitely help on that a little bit as well. Like we are kind of essentially having this kind of a very smart account abstraction layer that is like running as, it's not exactly account abstraction. It's like almost like a payment channel or a state channel type of thing that is like you're running on the side, that is like having a verifiable application. So you have all your money in this kind of a separate domain that is a verifiable application. You can pay each other easily. On chain, they're just all in the same account, but off chain, you're running just like a payment service, as if you're running a centralized service, but you're using ZK to generate the proof of all these kind of transaction settlement and everything, and settle it continuously on chain. So this is where really we see that there's like a very big opportunity there. That is you can essentially, right now, like if you look at the ZK powered application, the things that we build is like mostly half on chain and half off chain. Like you get a bunch of logic on chain, and if you want to do some very complex computation, you throw it in an off chain environment, generate the ZK proof, and do that. But like this type of, especially when we enter this AI realm and AI domain, we start to see that people coming up with this kind of idea where you have this kind of a dedicated application that is just running as almost like a centralized service. But the only difference here is that you're actually settling all the transactions in the centralized service to the blockchain directly, and then kind of settle there finally. So you can have all these kind of micropayments without even hitting the blockchain itself. And this is something that I think we can also collaborate and work on together as well in the future. I just like a thought of this, I guess.
For sure. I think I mentioned a very good point. All this is actually piggyback on the programmable money. The existing financial system has not been able to do this, deposits. I can hardly imagine, there is a different approach. There is a tokenized credit card approach. I can hardly imagine tokenized credit card approach able to support all this part. And then what we heard, from the programmable money, the most in-demand part is privacy. In this case, like how do I make sure my payment transfer is actually in like hide who is the sender, who is the receiver, blacklist, whitelist, and then this group bulk payment. And you mentioned state channel in this case. It's a per API cost state channel. In this case, that's all the requirement. But all this is only feasible because you have a programmable blockchain at the foundation for this. So that's why I think there is tons of the different use case. But what I saw, the most urgent use case is privacy, blacklist, whitelist, compatible with existing in blockchain. This escrow logic. Facilitator is actually, you can implement a different facilitator logic. There are tons of them. Like you can have escrow, you can have operator. All type of facilitator logic there.
Cool. Well, I guess like I have a last question for you guys. Like, for AI agent payments, what are some of the use cases that you already see live today that is pretty interesting and exciting? What are some of the upcoming kind of use cases that you see that are kind of exciting as well? Like, what are some of the kind of the future use cases that you see that's going to be like a pin killer use case for certain kind of market verticals, I guess?
I think so. Currently, what I see, maybe she can add more data points here. What I see is that the most common one for agent is still for delegation. So most of people use AI agent for delegation. Help me write research. Help me make purchase. Help me order Uber Eats. Planning a trip. So that's for automation. In that case, at the end of the day, you actually don't need, you can say, hey, do all the work for you, and then at the end of the day, just click the credit card, say approve in this case. Well, sometimes you need to fill like a 14 fields like for the credit card, but most people use agent for delegation. But I do see a trending coming. For example, I think less than a week ago, there is an agent help people to manage their portfolio, like agent, buying Bitcoin, Bitcoin.
Yeah, there's a race, right? There was a
yeah, like a dashboard. I can definitely say this is one of the earliest one because it requires almost like a zero. You have this kite passport, agent passport, and then you can enable agent ChatGPT help you to buy Bitcoin because you just need an agent passport to delegate the money to the agent in this case, right? And so that's one of the easiest way. But it's very hard to onboard a merchant or service provider to support this because you need to make sure all the service providers here, you need to accept stablecoin payment. You need to recognize which agent is interact with you in this case. Not only like just like a accept payment itself. It's like agent ID recognition, agent authentication, authorization, something like that. So that's why I think we're working with channel partner like PayPal and Shopify on this. So it probably take longer, but it's some use case agentic e-commerce in some use case we saw coming as well. I hopefully I think in the future, not foreseeable, in the near future, there is tons of the service and marketplace just for agent. For example, agent can rent a GPU, do some additional work for them. In this case, it's like I'm buying my lifetime. I'm buying a more powerful brain, help me do some research, and then agent can buy data. Agent can buy API. Agent can do knowledge search. I think this is coming as well.
Yeah, well, I'm looking forward to that day for sure.
Yeah. So just to actually also add on top of what Scott mentioned, I think the agentic purchase or agentic shopping experience or use case is probably going to be adopted faster in the enterprise world than the consumer world. So a lot of so again, still goes back to now, if I think back, it's not surprising. But the first time when I hear that use case or that needs from enterprise partners of us, it's indeed a little bit surprising that they found one agentic, like search and agent search and discovery is going to be very useful for them to do like a global, for example, like auto parts shopping from their more like downstream vendors, which is less to like the end consumers, but to enterprises or like to businesses, which actually is in some way easier for them or for example, like for networks like us to onboard because those people are doing more like a B2B transaction. So it's less of them, those vendors, and also for them, if their buyers, their business buyers are interested in those use cases, they're more willing to actually do those integration or like experiments with them because again, it's a B2B transaction that has a more volume or like a value per transaction than a normal consumer use case. And the another thing that like Scott mentioned, one I think a lot of the more like digitalized companies are exploring how they can monetize their data in the future. So one thing that I think it's still not happening, but it will happen soon probably, and also we'll see a lot of like the new business model or pricing model come out is how agents will be able to consume data or even like especially like data in fractional way from those data vendors, where like the companies who used to not be a data vendor but realize actually their data is new oil, for example, like Reddit, whose business model, especially last year, the main revenue actually come from selling their data to Google or some big companies for model training.
Cool.
Awesome. Well, I think we are this time really, like at the end of the podcast. But before we go, Michael, any last, insights or wish that you want to share with the community and audience?
Yeah. Well, so first of all, thank you for inviting me to the podcast. It's always great to chat with you too. And for us, like we see, AI definitely is the future. And I think verifiable computing is something that is like an own philosophy that guards the human society. Not against AI, but like essentially guard the environment we're kind of evolving into, or guard the society we're evolving into. And I think our thesis is that in the next 5 years, 90% of the blockchain computation, blockchain applications computation is going to happen off chain and hopefully happen in Brevis. And we're just looking forward to build with great teams like you guys and grow together in the ecosystem.
Definitely. And honestly speaking, it's such a great honor and also like luck to be able to work with the solid and really like a down to earth teams to push the future and blockchain space forward. So definitely looking forward to the collaboration. And like you guys mentioned, a lot of things for audience. We're Kaida and Brevis are cooking on a lot of collaborations and integrations under the table. So you will see some of the great things coming out soon. Yeah.
Some end-to-end use case. Let's build too.
In a verifiable way. So
okay.
Yeah, that's awesome. Thank you so much, Michael, and enjoy the rest of your day or night. Yeah.
thank you, True. Thanks.
Awesome.
Thanks.
Thank
Scott.
you. Have a good day.
Thanks.
Bye.
Bye.